Hi, this is a short video on DNA fingerprinting and how DNA fingerprinting is used to identify victims or parents or to identify people using that DNA fingerprinting. And I'm going to use this short video because it has really great graphics.
What is DNA fingerprinting or DNA profiling? Leicester University geneticist Alec Jeffreys developed a technique called DNA fingerprinting in 1985. It allows DNA samples from different people to be compared to look for similarities and differences. It's used for solving crimes and can also confirm if people are related to each other, like in paternity testing. Any two people in the world have 99.9% of their DNA the same.
Okay, this is referring to those gene coding sections of DNA. In the previous film on DNA profiling, we were looking at the non coding sections. And those non coding sections are going to be the main differences between individuals. And so, about 0.1% of your DNA is referring to the non coding regions. This 99.9% refers to the coding regions of your DNA.
So this process analyzes the differences in the remaining 0.1%. This modern technology is called DNA profiling. It's a very sensitive technique which only needs a few skin cells, a hair root, or a tiny amount of blood or saliva. There are sections, or loci, of chromosomes, where instead of a gene consisting of a long sequence of bases, there are much shorter sequences of 3, 4, or 5 bases that are repeated many times. For example,
This is showing the short tandem repeats. This is what they're talking about. They're talking about their different lengths and their different numbers of those short tandem repeats.
these repeated sequences are called short tandem repeats, or STR. At these places on the chromosomes where we find these STRs, there are areas that vary in number of repeats. DNA profiling only looks at these STRs. A cell sample is collected. This could be from some blood at a crime scene, or a swab from the inside of someone's cheek, for example. The DNA is then extracted from the sample. Many copies of this DNA may be made using the polymerase chain reaction, or PCR. Special enzymes called restriction endonucleases are used to cut the DNA up into different sized pieces. The DNA samples are then put into wells in a special gel called agarose for the process of gel electrophoresis, which separates the DNA fragments by size. The pattern is then transferred to a nylon sheet in southern blotting. And finally, the lines produced by the DNA samples from different people are compared.
Okay, so here it's showing in the previous clip we only showed one piece, that just the one length from the non-coding region. These are going to be several lengths of DNA from non-coding regions of each person versus these blood samples. And when looking at this, you're comparing where those DNA strands line up on the gel pan or on the southern blotting sheet.
So let's have a go at using DNA profiles to solve some mysteries. An item was stolen in a burglary. A drop of blood was left behind by the thief. Samples of DNA were taken from 4 suspects and compared to the sample left at the crime scene.
Okay, so in this DNA profiling case, we're looking at the blood stain here that was collected at the scene of the crime. And what we have to do as forensic scientists is compare the non-repeating codes, those strands, to the other suspects. And we can clearly see here all of these line up. But you have these two lengths here that are lining up with suspect 3. And we can go on to verify that this blood sample is coming from suspect 3. And so in this case, the culprit is going to be suspect 3. I'm going to forward our video just a little bit to um, look at our next case. The next case is comparing parents' DNA. Now, as you know, your parents' DNA, you have half from your mother, half from your father. And so this soldier, they're trying to identify the soldier, and they've collected DNA samples from parents. And if we look and compare the bands of the soldier to the parents, we're looking for a combination. And so if we look close enough, we see this band matches with parent D, this parent matches with parent C, 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 D. Okay. Parents C and D are going to show that they have the most DNA in common with the unidentified soldier. Okay, that would be a case of maternity and paternity, of identifying a victim. If you have any more questions or you need to go back and pause the video and take notes, please feel free to do so. That is DNA in a nutshell.